In this video, we're going to go over how to solve compound inequalities involving the word OR. Now, solving the OR compound inequalities require really not much extra steps mentally above what you already know how to do. The central idea is this: since an OR inequality is true for either one inequality or the other one, we keep them separate the entire time, right? You've noticed with the graphs that you're either graphing one side or the other. So they're two separate inequalities, just kind of combined together. So that's what we're going to do with these problems. You solve them like separate inequalities with the word OR. It's not so bad. So we've got 8b minus 58 is greater than 14, or negative 2b plus 16 is greater than 5. We'll solve this first one. So I'm going to add 58 to both sides of the inequality. And from there I get 8b is greater than 14 plus 58, which is 72. Then I solve like any normal inequality, isolating b by dividing both sides by 8. And you're left with b is greater than 9. So we solve that one inequality. We don't have an overlapping inequality like an and, so I just go to the other one and solve it like normal. I subtract 16 from both sides to isolate negative 2b. The plus 16 cancels, and I'm left with negative 2b minus 11. Notice we're going to be dividing by a negative number here, so look out. Inequality signs are going to be switching. So negative 2 divided by negative 2 is 1, and we're left with b. It's no longer greater than, because we divided by a negative number, is less than negative 11 divided by negative 2 is a positive 11 halves. And the key word here is that we have OR. So b is either greater than 9 or b is less than 11 halves. We're going to graph our solution, just like we've been doing in the past. So 11 halves comes before 9, so I'll put that over here. And 9 is right here. So let's graph each one independently, just like we did with other OR inequalities. b is greater than 9, so be an open circle, shaded to the right. Or it is less than 3 halves. Open circle, shaded to the left. Not bad. That's it. Solve them like separate inequalities and rock and roll like you know how. Remember, it's OR, so it's either this one is true or that one is true. They're kept separate. So into this problem we'll do, just to again exercise a similar idea and get practice on one more problem. So I'd add 7 to both sides, solving this inequality like normal. That leaves me with 5z, as the 7's cancel, is less than or equal to negative 20. I want to undo 5 times z, so I divide both sides by 5. And that leaves me with z is less than or equal to negative 4. Don't be fooled by the fact that negative 20 is a negative number. We actively divide it by positive 5, which is why the inequality sign does not switch. All right, on to this next part. I'll just throw down the OR right away, because we know it's going to be OR this one. I subtract 3 from both sides. That leaves me with 2z is greater than 3. And I divide by 2 to isolate z. So your equation solving skills are in full effect here. So I guess I'll bring this down here. I didn't space that out well. We have z is greater than 3 halves. So we have either z is less than or equal to negative 4 or greater than 3 halves. Here we go. Graphing this out, I'm at negative 4, including negative 4, or less than it, or an open circle, nowhere equal to, greater than 3 halves. And that's it. OR inequalities, it's as simple as treating them like two separate inequalities and rocking them like you know how.